Look at a newborn baby on the night it is born. A few pounds of a brand new person with a name someone has only just printed on the little hospital bracelet around its wrist. Here is the strange part. That baby is one of the least likely things in the entire universe. Not because being born is rare, but because of everything that had to happen first. A chain of events running back long before the hospital, long before Earth, long before the sun, all the way to the first stars. We tend to think a life starts at birth. It doesn't. By the time a child takes its first breath, the hardest part of the story is already billions of years finished. A single family line had to survive down to 2 people, but before that, our whole species had to slip through moments when it very nearly disappeared. Before that, complex life had to appear at all, on a world that somehow stayed livable for an almost unreasonable stretch of time. And before any of that, the universe itself had to build the ingredients, generations of stars that lived and died to forge the atoms now sitting inside that baby's body, a calm corner of a galaxy, and a rocky planet in the right orbit around the right kind of star. Tonight, we are going to follow that chain the whole way down. We start with one human being and work backward, through the survival of a single lineage, through the near misses in our species' deep past, through the slow arrival of complex life, through billions of years of a planet holding itself together, and finally to the physics that had to fall into place before a world like Earth could exist at all. We are not building toward a miracle, and not toward a number pulled from thin air. Every layer has real evidence and real limits on what we can measure and what we can only estimate. Where the proof runs out, we will say so plainly. Before we settle in, if you enjoy exploring questions like this with me, subscribing helps others find their way here too. And I would genuinely like to hear your thoughts below. I read every single comment. Now, let's begin. So if this bracelet is already late in the story, what earlier chain made it possible? Start with something that sounds simple. Homo sapiens survived. That much is true. Our species made it through ice ages, population bottlenecks, migrations across continents, and extinctions that eliminated every other branch of the human family permanently. The Smithsonian's human family tree shows those dead branches clearly, lineages that lasted hundreds of thousands of years and then stopped. Ours did not stop. That is the wide claim. And when most people hear it, they take it for granted that you followed from it, that one fact leads naturally to the other, as if the rest is just family detail. But there is a gap in that assumption, a significant one. Think about a highway staying open. The road is there, traffic can move, but a specific car, your family's specific car, making one particular trip to one particular house, still has to get through every junction along the way. Someone has to take the right exit. Someone has to turn at the right moment. The highway being open does not place any specific car in any specific driveway. Your existence needed that highway, and then it needed every turn after. Even after Homo sapiens was clearly going to persist as a species, your particular life still required one surviving lineage on your mother's side and one on your father's. Those 2 lines had to reach the same place at the same time. A specific pairing had to happen. One outcome out of hundreds of millions of possibilities in a single moment. Change any piece of that, any meeting, any timing, any gamete, and the chain does not produce you. It produces someone else, or no one. The species question and the person question are not the same question. So humans existed, and you existed, are not neighbouring claims. They are not even the same size of claim. One describes a wide population making it through. The other describes a vanishingly narrow sequence of contingent events, stacked one on top of another. Same highway, entirely different driveway. This is not about making you feel rare or chosen. It is about the actual physical structure of how any particular life comes to exist at all. Species survival is the wide end of the funnel. A specific person is the narrow end. And between those 2 points, the chain passes through a long list of moments that had no particular reason to go the way they went. Tonight, we are going to follow that chain, not just back to you, much further back than that. The frame is going to keep narrowing, and we are going to keep following it, all the way down to where the chain almost did not hold. And if one person is narrower than one species, why does the finished chain feel so ordinary? Here is one reason. When you look back along a chain that worked, the dead ends disappear. You only see the path that made it through. Every branch that went nowhere is simply gone. No record, no marker, nothing to remind you it was ever a possibility. What remains looks clean. It looks like a route. Think about a maze. If someone hands you the answer key, the solution looks obvious. One clear line from entrance to exit. But that printout does not show you the dozens of passages that dead-ended. The answer key erases them. The maze still had them. You just cannot see the ones that failed once you already know which way worked. The hominin record works the same way. The Smithsonian's Human Family Tree lists more than 20 species that we know about, and those are only the ones that left enough behind to be found. Most of them ended. Branches that ran for hundreds of thousands of years and then stopped. Populations that never made contact with the line that continued. The record is crowded and broken and full of gaps, and it only feels like it points somewhere because we are standing at the end of it. The branch that kept going is the only one still around to feel obvious. None of that is the chain proving it was always going to work. It is the chain proving that one version survived, and that survival is now the only version you can see. That is the trick. Not that the outcome was impossible. The documentary is not saying that. It is saying that once something has already worked, the mind smooths the route backward. The contingency gets flattened. All the moments where the result was genuinely in doubt get filed away as though they were not real obstacles, because the chain passed through them. Hindsight does not lie exactly. It just quietly removes the other exits. So strip that away. Do not start from the outcome. Start from any single point along that chain, and ask what it needed in order to keep going. Not what it did need, what it needed. The answer, almost every time, is a specific set of conditions that were not guaranteed, conditions that came from somewhere further back, which means the chain could have broken there, which means something before that point had to be in place for this point to even be reachable. Once you see that, the next real question is not about you or your parents or even the species. It is about the world those earliest links were threaded through, whether that world was the kind that could hold a chain at all. If hindsight is the trick, how far back do we have to go before the chain could even begin? Astrobiology, the study of where life might exist and why, treats the whole question as a problem of chemistry. Water, energy, the right kinds of atoms, a stable enough place to put them. That framing counts. It does not say life was coming no matter what. It says life needs a minimum inventory, and the first question is whether the universe bothered to produce that inventory at all. Most people skip that question entirely. If a universe exists, the thinking goes, then eventually you get planets, and eventually you get something alive. Rocky worlds feel like the default. Wet chemistry feels like a given, but that image skips over a boundary that came much earlier than any planet. Think about baking bread. You can have an oven, you can have a recipe, you can have time. None of it counts if flour was never invented. The later steps depend completely on whether the earlier ones produced what they needed to produce. The universe ran into the same problem. The atoms that make up your body, carbon, oxygen, nitrogen, iron, were not there at the beginning. The early universe was almost entirely hydrogen and helium. The heavier elements, the ones that let chemistry get complicated, had to be forged inside stars and then scattered outward when those stars died. That process takes time and the right kind of stellar life cycles. Without it, there is no carbon. Without carbon, there is no organic chemistry. Without organic chemistry, the later questions about planets and cells never get asked. Long-lived energy sources matter the same way. A world needs a star stable enough to keep things warm over vast stretches of time, not a blaze that burns out in a few 100 million years before anything can take hold. And none of this is a fine-tuning argument. Nothing here says the cosmos was leaning toward us. It is simpler than that. Certain ingredients had to exist before any of the later layers were even possible. The chain does not start with a cell, or with a planet, or with a solar system forming in the right place. It starts with whether the universe produced the raw material that all of those things are built from. And here is the part that counts for where we are going. Having the ingredients is not enough. Flour does not become bread on its own. A universe full of carbon and water and long-lived stars is still just a universe full of useful atoms. But ingredients alone are cheap. What makes a world more than a pile of useful atoms? Think about what it would take to keep a premature baby alive. Temperature makes the difference. Oxygen levels matter. Humidity counts. Timing counts. None of those things works in isolation. If even one drifts outside its range, the others stop being enough. A hospital incubator is not one dial. It is a set of conditions that have to hold together all at once for as long as it takes. A planet is something like that. The simple idea is appealing. A rocky world sitting at the right distance from its star, not too hot, not too cold, and you start imagining life almost automatically. That view has a name. Scientists call it the habitable zone, and it is a real and useful idea, but it is thinner than it looks. Researchers who study habitability in detail treat it not as a stamp that gets applied once, but as something a world moves through, more hospitable here, less hospitable there, depending on conditions that shift and stack. Water is part of it, so is having an atmosphere thick enough to hold pressure. So is temperature range, not just average temperature. So is the chemistry of what is actually dissolved in that water, what energy sources are available, and whether any of it persists long enough for something slow and complicated to build up over time. Being in the right place around a star is only the beginning of the test. And that shapes how you imagine humans came to be possible. Because every time someone says a world looks promising, what they really mean is it has passed one condition. There are others waiting. Some worlds have liquid water and the wrong chemistry. Some have the right distance and no magnetic protection worth mentioning. Some have the atmosphere but lose it. No single factor gets to be the whole explanation. The research is careful about that. One missing condition on that list is enough to change the outcome. So when you hear promising world, it helps to hear it the way a doctor might. Promising means worth watching. It means the first few readings came back in range. It does not mean the story ends well. A world that looks good on one measure is only at the start of a test. And even if a world looks promising once, can it stay that way long enough for any story to unfold? And that question is really about time. Think about a candle under a pot. It can cook dinner, but only if the flame keeps going. Light it, walk away, and the flame dies in a draught. Come back an hour later and you have a cold pot and raw food. The candle being lit once was never the point. The point was staying lit. A world works the same way. Looking promising once is not enough. The process that builds anything complex takes an enormous span of time. Not years, not centuries. We are talking about hundreds of millions of years, maybe billions, of conditions staying inside a range that allows chemistry to keep building on itself. One good interval does not do it. The interval has to hold. This is what makes the habitability question explicitly a time question and not just a materials question. Researchers who study planetary conditions, including work published through NASA's astrobiology program and studies by Mendez and colleagues on what keeps worlds in play, frame it this way deliberately. A world has to remain usable. It has to arrive with the right ingredients and keep conditions steady long enough for those ingredients to do anything with each other. Promising once is a much weaker claim than usable for a very long time. You can see why this counts when you think about your own planet. Earth is somewhere around 4.5 billion years old. The first recognizable life appeared within the first billion years, roughly. But the things that eventually led to you, complex cells, then multicellular life, then everything after that, those came much later. There was no shortcut. The time had to be there. A world that had all the right materials but ran out of usable time after a few 100 million years would have left nothing behind. No fossils, no signal. Nothing. Here is what this does not mean, though. Long-lived does not mean calm. It does not mean stable in any comfortable sense. It does not mean the world spent billions of years sitting quietly in perfect conditions, waiting. Earth's long history includes intervals that almost ended the story several times over. The duration is real, the comfort is not. So when the question shifts from can a world form in the right place to can it stay usable, you are not asking a simpler question. You are asking something harder. The cosmic setup makes the difference. But then the planetary work begins, and it keeps going for a very long time. So what did a long-lived world like Earth actually have to do for billions of years? Think about a sourdough starter. Not the loaf, the starter. The jar of living culture someone keeps on the back of a counter for years, through summer heat and winter drafts, through neglect and revival. Getting one good loaf is easy. Keeping the culture alive through every changing condition for a decade is the harder thing. Earth is not the loaf. Earth is the starter. When you imagine Earth as a habitable planet, you probably imagine something close to now. Blue oceans, breathable air, moderate temperatures. That version of events is real, but it is a snapshot from the last heartbeat of a very long story, and the danger is mistaking the snapshot for the whole thing. We live on a short time scale. A human lifetime is so small against planetary history that everything around us feels fixed. The continents, the seasons, the ratio of gases in the air you are breathing right now. It feels stable because on our time scale, it mostly is. Deep time is the opposite of that. Deep time is a world that barely resembles any single photograph you could take of it. Here is what researchers studying planetary habitability have found. Habitability is graded, not binary. A 2021 review looking across Earth's history found that the planet did not lock in one permanent livable setting and hold it. It moved through different atmospheric and ocean states over billions of years. Oxygen levels shifted dramatically. Global temperatures swung between conditions that would be alien to anything alive today. The oceans changed chemistry. The whole system kept reconfiguring, and through most of that, something kept the chain from breaking. That is the fact worth sitting with. Habitability was not a single achievement. It was a long project of staying usable through change, not perfect change, not comfortable change, just enough. The threshold kept being crossed, and then crossed again in the other direction, and then again. What counts for a later story, a story that eventually includes anything as complex as you, is not that Earth got the setup right once. It is that the planet persisted through different regimes without the chain snapping. Every change in that deep history only counts here for one reason. It either kept the next step possible, or it almost did not. The geology is not the point. The persistence is the point. And persistence means something kept shifting at the planetary scale for a very long time, while life was still too small to notice any of it. If the planet had to last, what changed most dramatically while life was still simple? You probably imagine oxygen arriving the way a light turns on. One moment dark, the next moment bright. That is not what happened. Think of a dimmer switch instead, one that someone turned up over billions of years, pausing, stopping, reversing, and then lifting again. The room never snapped to full brightness. It crept there, unevenly, floor by floor. The rock wreckage shows this clearly. Around 2.5 billion years ago, oxygen began building up in the atmosphere for the first time. You can see it in the stone, minerals that only form when oxygen is present, laid down in thin bands, telling geologists that something changed in the air. That first rise is real. But calling it oxygen arrives makes it sound like a delivery. One event, one date, done. The oceans did not get the same message, not then. The deep ocean stayed oxygen poor for a long time after the surface air had begun to shift. The two systems were running on different clocks. Atmosphere and ocean, same planet, very different chemistry, for hundreds of millions of years. Life in that era did not inherit a clean world. It inherited a world still sorting itself out, layer by layer, depth by depth. If you stop there for a second, you can feel how incomplete that world still was. And near-modern oxygen levels, the kind that would eventually support large, complex, energy-hungry animals, Those came much later. Not a quick planetary makeover, an immense delay. The gap between first atmospheric oxygen and anything approaching modern levels stretches across more time than animals have existed at all. That is not a small asterisk. That is most of the story. So when someone says Earth became habitable, it helps to ask, habitable for what and when? Microbial life with low oxygen needs? Yes, for a long stretch. Complex life needing rich, consistent oxygen throughout the water column and the air? That took far longer. The planet was not one thing. It was a sequence of different planets, each one hosting whatever biology could manage under the conditions it actually had. If you keep the later animal story in view, that delay is the point. The planet stayed usable, but it did not stay usable for every kind of life at once. The later animals did not inherit a finished world. They inherited a planet that had been remaking its chemistry for eons before they arrived, and that was still not entirely settled when they did. The oxygen was there, in the end, but it arrived in installments, not all at once. And if oxygen rose only in stages, what does that say about the kind of world later animals needed? It says the world was never finished, not even close. A planet that stays usable is only keeping a door open. It is not deciding who walks through. For you, following this chain forward to later animals, that means the stage never stopped moving. Think about adjusting the temperature in a shower when the pipes keep shifting underneath your hand. You find a comfortable balance, then the hot line drops, and you compensate. Then the cold line surges, and you compensate again. You are never in control of the system. You are just managing it moment to moment, trying not to get scolded or frozen out. Earth has been doing something like that for 4 billion years, not settling into a safe configuration. Adjusting, continuously. The habitability record shows this clearly. Researchers tracking the planet's overall suitability, Mendez and colleagues in 2021, found that Earth has stayed within a livable range for most of its history. That staying within range is different from being stable, and work by Lyons and colleagues on the oxygen record, published in 2014, showed that the atmosphere did not simply rise to a breathable level and hold. It climbed, stalled, partially retreated, climbed again across hundreds of millions of years. The planet kept working. It never stopped changing while it worked. The combination, persistence under change, not early perfection, is what the habitability story actually tells you. The planet was not laid out in advance as a safe home. It was a place that kept buying time forward, without guaranteeing what that time would be used for. So the question shifts. It has to. Once you understand that Earth stayed usable by constantly renegotiating its own chemistry, the old version of the question stops making sense. Asking whether a world can exist and remain habitable is no longer the hard part. Something much more specific becomes the hard part. What happens once life enters a world that keeps changing under it? What does that shifting ground do to a chain of events that has to run correctly, step after step, across billions of years? That is where the story gets harder. A stable world would have been generous. A world that persisted by adapting gave life a place to start. It did not give life a smooth path forward. The door stayed open. What came through, and when, and whether any of it led anywhere, that is a different question entirely. Suppose life begins on such a world. Why does that still leave the chain mostly closed? Suppose life begins. That is not nothing, but it is not the same as saying the path forward is open. Here is the story most people carry. Life appears, and then the clock starts running toward everything that followed. Cells, then complexity, then eventually something like us, as if the first spark guarantees the fire. Think about wet wood. A spark can catch in it. That is real. The wood is burning. But wet wood does not mean the fire lasts through the night. A spark catching and a fire that runs until morning are two entirely different things. One tells you almost nothing about the other. For 1 billion years or more after life took hold on the early Earth, the atmosphere had almost no free oxygen. The sky was essentially anoxic, nitrogen, carbon dioxide, traces of other gases, but not the oxygen-rich air that animals need. Life was there. Chemistry was happening. Cells were dividing in the dark, in the water, doing what single cells do. But the stage itself was hostile to almost everything that would eventually come later. You could stand on that planet, in whatever sense that phrase means for a world without land you could breathe on, and it would look alive under a microscope, completely empty to your eye, the ocean moving, nothing else moving. What this means is that a living planet can stay stubbornly simple for an enormous span of time. The existence of life does not open the path to complex life. Those are two separate sentences, and they do not follow automatically from each other. The first can be true for 1 billion years, while the second stays closed. How long is 1 billion years in terms you can feel? If Earth's whole history were a single night's sleep, microbial life shows up early and then just holds. It holds and holds. Animals do not appear until roughly 40 minutes before your alarm. For most of the night, life is there and the world is still. This bears on the chain of events we have been tracing. The chain does not just need life to appear, it needs life to go somewhere. And what the early record shows is that going somewhere is not the automatic next step, it is a separate requirement, with its own obstacles running across a completely different timescale. How life first assembled from chemistry is a question this does not answer. That boundary is real and it stays open. What we can say is that once life was present, the path forward was not waiting for it. The world stayed hostile in specific ways. The atmosphere stayed closed. Something had to change the stage before anything larger could walk on it. Life arrived early. The path to us stayed mostly shut. If that is true, what kept it closed for so long? If life arrived early, what kept it from becoming anything like us for so long? That question has two parts that look like one. Getting life started is one test. Keeping it alive across a young, unstable planet is a different test entirely. Passing the first one does not guarantee passing the second, and passing both of them still does not get you to animals or mammals or people. Those are further tests, with their own requirements, running on their own schedules. Think about a seed sprouting in rocky soil. The fact that it sprouted tells you something real. Conditions were enough, chemistry worked, a beginning happened. But a sprout is not a tree, surviving decades of storms, dry summers, competing roots, shifting ground. That is a separate story, running much longer, with no guarantee of a particular shape at the end. Early life seems to have been something like that sprout. What the record suggests is not a quick climb toward greater things, it suggests durability, staying power under difficult conditions. Researchers working on ancient microbial evidence, including work connected to NASA astrobiology programs and scientists like Andrew Knoll, describe a world where simple life persisted, not a world where complexity was assembling itself on schedule. The evidence points to organisms that held on, not organisms racing towards something more. And here is what that means for the timeline you might be picturing. Simple life can occupy a planet for an enormous span of time without producing anything you would recognize. No shells, no limbs, no nervous systems, just chemistry, persisting, dividing, drifting. If you compressed Earth's biological history into a single night, the stretch from first life to anything with a body is most of the night, almost all of it. The complicated forms show up very late. That delay is not a puzzle to be explained away, it is the actual shape of what happened. Life did not treat complexity as the obvious destination, it treated survival as the whole job, and survival for a very long time meant staying small, staying simple, staying alive in conditions that would end most things we know today. So the early presence of life does not compress the road ahead, it just confirms that the road existed at all. What comes next required the planet to change in specific ways. The atmosphere had to shift. Conditions that made larger, more energy-hungry organisms possible had to arrive. That arrival was not written into the first cell that divided in shallow water. Something had to open the door. So how do we say clearly that a living planet is still nowhere near a human world? Think about a single occupied cabin in the wilderness. Someone is living there. There is warmth, food, a fire at night. The wilderness is no longer empty, but that one cabin is not a city. It is not roads, plumbing, power lines, or 10 million people who have never met each other. The cabin and the city are separated by an enormous distance that patience alone does not close. Something has to be built between them. A planet with microbial life is the cabin. You have biology, you have chemistry that replicates itself and responds to its environment. That is genuinely extraordinary. But you do not yet have eukaryotes, cells with an enclosed nucleus, cells that can store and manage far more genetic information. You do not have multicellular organisms. You do not have animals or anything on the road to them. These are not just later stages of the same process. They required new conditions. Oxygen in the atmosphere at levels that made larger, more energy-hungry organisms viable. That oxygen built up slowly, over hundreds of millions of years, produced by photosynthetic microbes as a byproduct. It was a planetary change, not just a biological one. The atmosphere had to become a different atmosphere before the next door could open. And the evidence for that transformation is part of the record. It is not a philosophical footnote about patience. It is a real gap, measured in the chemistry of ancient rock. This is where the misconception earns its correction. The idea that once a planet is alive, humans are just a matter of waiting long enough. That is the cabin-to-city problem in disguise. You are assuming the infrastructure will build itself. It will not. Each transition required something specific. A chemical shift, a structural change in the cell, a new source of energy that smaller organisms had not needed. None of those transitions were guaranteed by the first replication event in warm, shallow water. And here is the part worth holding on to. Microbes were not a failed draft. They were not marking time. For most of Earth's biological history, they were the whole story, and they were doing enormous work, reshaping the planet's chemistry, building the conditions that eventually made everything else possible. The point is not that they were unimportant. The point is that they were not the same answer as what came later. A living planet is real. That is what counts. But it leaves the hardest question completely open. What finally widened the chain beyond microbes, and why did it take so long? That question has an answer hiding in plain sight. The delay itself is the evidence. Think about what the timeline actually shows. Life appears on Earth early, not after a long empty wait, but within a few 100 million years of the surface cooling enough to hold liquid water. Microbial chemistry was running almost as soon as the planet allowed it, and then it ran and ran and ran for something close to 3 billion years without producing anything you would recognize as complex. No nucleus inside the cell, no true multicellular body, no tissue, no coordinated organism made of parts doing different jobs. 3 billion years is difficult to hold in your head, so try this. If Earth's entire history were a single night's sleep, 8 hours, from the moment you close your eyes to the moment the alarm sounds, animals do not show up until roughly 40 minutes before you wake. For most of that night, the planet is alive. Genuinely, chemically, biologically alive. But there is nothing that resembles what you would call a plant, or a creature, or anything you could see without a microscope. The night is long, the change comes late. This is what makes the delay matter as evidence. When you look at a timeline graphic of Earth's history, the illustrations often frame the story as a staircase climbing toward us. Each step looks like progress, but the long stretch in the middle, the part that looks almost empty, is where the real information lives. The chain did not widen, it stayed narrow. Life was present the entire time. Complexity was not climbing, it was waiting, for reasons the planet itself had not yet supplied. Andrew Knoll and Martin Nowak, reviewing the deep history of life, have pointed to this gap as one of the clearest pieces of evidence against a smooth progress story. Given enough time, the argument goes, complexity simply climbs upward on its own. But 3 billion years of microbial stasis is a hard fact to fit into that image. Time alone was not enough. Something else had to change. The point is not that complex life was impossible elsewhere, or that it required some special cosmic permission. The point is narrower than that. On this planet, with life already running, the chain stayed thin for longer than the entire history of animals by a wide margin. That is a constraint worth taking seriously. It asks what the planet was missing, not what life was missing. And that question pulls in a specific direction. If the delay is the clue, what changed in the planet itself before larger life could spread? Think about a town built on dirt paths. People can live there. Commerce happens. Generations pass. But you cannot put up a hospital, a factory, a 10-story building until roads are paved, water runs through pipes, and power reaches every block. The infrastructure has to arrive first. The larger structures follow only after. That is roughly what happened to this planet's chemistry, and it happened in stages, not all at once. The first shift came roughly 2.5 billion years ago. Oxygen began accumulating in the atmosphere for the first time. Researchers call this the Great Oxygenation Event. It was not a small moment. Before it, the air held almost none. After it, oxygen became a permanent feature of the world above the surface. And that shift appears connected to one of the biggest jumps in cellular complexity, the arrival of eukaryotes, cells with a nucleus, cells capable of far more internal organization than anything that came before. But here is where the idea gets more careful. Biologists Andrew Knoll and Martin Nowak have described how that first oxygen rise tracks with eukaryotes, while a much later rise, the Neoproterozoic oxygenation event, roughly 600 million years ago, tracks with something different. Large, complex, multicellular organisms, the kind of animals and relatives of animals you would recognize. Two events, separated by nearly 2 billion years. Different biological thresholds, each waiting for its own environmental opening. Geochemist Timothy Lyons and colleagues have pulled together evidence showing that the rise of oxygen through the oceans and the atmosphere was not a clean line upward. It was uneven, patchy. The deep oceans stayed oxygen poor long after the surface changed, different chemical zones shifting at different rates. The infrastructure was being built, but slowly, incompletely, one section at a time. So oxygen did not unlock everything at once. You might imagine a single switch. Oxygen appears, evolution accelerates, complexity follows naturally. But that is not what the record shows. The eukaryotes arrived and then waited through hundreds of millions of years while the planet's chemistry continued its slow, uneven climb. Larger life belongs to a second opening, not the first. It was not the automatic next step, it was a delayed one, contingent on conditions that took an enormous stretch of time to arrive. That is not a small distinction. It means the chain did not simply widen once oxygen showed up. It widened twice on a schedule the planet set, not life. And each widening had to wait for the last one to settle. And once the path finally widened that second time, did the chain at last relax? And once the path widened, did the chain finally relax? Not the way you might hope. Think about a highway where a bottleneck has finally been widened. Extra lanes open up, traffic can move again, more cars get through than before. That is real progress. But opening extra lanes does not tell you which single car will still make the right exit at the end of a very long drive. The road ahead still branches, still narrows, still closes without warning. That is roughly where life stood once larger multicellular bodies began appearing. Something genuine had changed. The gate that had held complex organisms back for so long had finally opened. That makes the difference. But one gate opening is not the same as all later gates disappearing. The evidence here shifts the answer in a specific way. What the timing of delayed complexity tells us is that one enormous condition was finally met. Not that the conditions requiring survival afterward were lifted. The chain gained access to a wider path. It did not gain immunity from what the path still held. And the path still held a great deal. Severe environmental filters were waiting further along. Planetary conditions continued shifting. Oxygen levels that had climbed to allow complex bodies would swing again over millions of years. Ice episodes arrived that were not gentle. Volcanic events altered atmosphere and ocean chemistry in ways that had nothing to do with how well life had organized itself at the cellular level. The chain remained exposed to pressures that had no interest in what had taken so long to assemble. There is a version of this story that sounds like relief. Complex life finally appears, and the long, hard part is over. The rest is a matter of time. Animals, then land animals, then something like us, a sequence that feels, in hindsight, almost automatic. That version is not what the record supports. What the record supports is that one constraint lifted after an extraordinary delay. That lifting was real and significant, but the organisms that passed through the newly widened gate entered a world that still had its own serious filters ahead, ones capable of resetting large portions of what had accumulated. The chain that reached multicellular life was longer and more contingent than it looked, not shorter. The path widened. The exposure did not end. So if the chain remained vulnerable after complexity finally appeared, the next question lands quietly here. What kinds of severe filters still had to be survived before later animals inherited the world? If not, what kinds of severe filters still had to be survived before later animals inherited the world? Here is one answer, and it starts with cold. Not the ordinary cold of a long winter, something far more total than that. There were periods, scattered across deep time, when glaciers did not stop at the poles. They kept going. Ice reached the tropics. The oceans may have frozen over entirely, or close enough that the difference barely mattered for the creatures trying to live beneath the surface. Scientists call this snowball Earth. The geological record holds the evidence in glacial deposits, layers of rock that could only form under extreme global-scale glaciation. Researchers examining those deposits have traced at least two major episodes, the Sturtian and the Marinoan. Each one was tied to upheaval in the carbon cycle, in nutrient availability, and in the composition of the biosphere itself. Think about what that means for life. You have organisms that have been building complexity for hundreds of millions of years, and then the planet wraps itself in ice. Here is the analogy that holds. A patient who survives a brutal fever does not owe the fever a thank you. The fever was not helping. The patient simply did not die. What survival proves is not that the ordeal was necessary or beneficial. It proves that survival still had to be won. That is different. Snowball Earth fits here in the same way. Life came through, but coming through is not the same as being guided through. Researchers like Knoll and Nowak have argued that severe environmental disruptions belong in the story as real evolutionary constraints, not as passive scenery that life simply ignores on its way somewhere else. The glaciations were not background, they were pressure, and the biosphere had to remain viable through each one. Now, this lane stays clean if it stays bounded. The evidence for what Snowball Earth specifically selected for, or what it ruled out, is thinner than the evidence for other filters in this story. What can be said plainly is that the world experienced these events and that they were severe. Whatever life continued afterward had already run one more long gauntlet before familiar animals were anywhere in the view. The misconception worth releasing here is that deep time before the dinosaurs was a long, uneventful warm-up, a slow accumulation of complexity in stable, forgiving conditions. The record does not support that mental image. The narrowing began early. The pressure was already real, long before any creature developed eyes or bones or the ability to sense the danger it was in. So if even a frozen planet was only one filter in a longer sequence, the question that opens next is quieter but heavier. How should we think about the harsher resets that came later? Think about a citywide blackout. The power fails everywhere at once. But what happens next is not even. Some families have candles, a gas stove, a neighbor with a generator. Others have nothing. The blackout does not choose who inherits the morning. It simply changes who can keep going when the lights return. Mass extinctions work something like that. Researchers who have looked hard at the big extinction events across Earth's history found something important. There have been at least 5 that qualify as major, but they do not all belong to the same category of disaster. Each one has what scientists call ultimate causes, the deep conditions that made the crisis possible. Each one also has proximate kill mechanisms, the specific things that actually ended so many lineages. Volcanic outgassing over hundreds of thousands of years is a different kind of pressure than a fast asteroid impact. Ocean oxygen collapse kills differently than rapid temperature swings. The trigger classes are not interchangeable. That counts because the misconception sitting quietly underneath a lot of extinction talk is that catastrophe is catastrophe. One disaster story can stand in for any other. A giant rock hits, most things die, a few survive, repeat as needed. But that framing flattens something important. Different resets left different survivors. Different survivors meant different futures. The question that actually counts after each extinction is not which catastrophe was the most dramatic. It is which branches were still standing when the pressure lifted, and whether what they inherited gave them somewhere to go. No single one of those events explains the chain that eventually produced you. Each one narrowed the options. Each one changed the topology of what was possible. Together, they were not one catastrophe. They were a sequence of uneven reshufflings. That sequence delivered the particular set of animals that were alive when the next filter arrived. You are not the product of one dramatic reset. You are downstream of a long series of them, each one selecting in its own way, each one leaving a world slightly different from the one before. So when the conversation turns to Chicxulub, to the asteroid that ended the dinosaurs, it is worth holding that frame. It was a real event, a significant one, with real consequences for the branches that remained. But it was one strong case inside a larger pattern, and among all those later resets, why does that particular one matter without letting it become the whole story? And among those later resets, why does Chicxulub matter without becoming the whole story? It is the point partly because the evidence is so clear. The iridium layer in the rock record is sharp and global. Fossil pollen shifts abruptly across the same boundary. Jan Vellekoop and his colleagues documented the thermal disruption in sediments from that period with unusual precision. The broader synthesis of the impact record leaves little room for serious doubt about what happened 66 million years ago and when. That clarity is rare in deep time. Most filters leave blurry signatures. This one left a line you can put your finger on. Think of a filing cabinet stuffed with cases, some thin, some contested, some half legible from age. Then one folder near the back is thick and well organized, with dated photographs and corroborating witnesses. That folder is Chicxulub. It is not wrong to read it carefully. The problem is when the one readable file starts to feel like the only file, like the cabinet itself. That is what happens in most popular tellings. The asteroid arrives, and the documentary has found its spine. Everything before becomes setup, and everything after becomes consequence, as if the whole chain existed to produce this one vivid moment. It did not. Chicxulub was a filter inside a much longer sequence of filters. Its evidence is strong, but evidentiary strength is not the same as causal centrality. The loudest file in the cabinet is still one file. What the impact actually did was change who inherited the future. It did not reserve a seat for anything in particular. The lineages that made it through were not chosen or protected. They survived because of what they were: small, adaptable, able to persist on whatever the collapsed food web still offered in the years after. A different set of survivors would have branched differently. The world that eventually produced you was not written into the event. It was one of the possible worlds that came out the other side. So the right relationship with Chicxulub is to take it seriously on its own terms. It was a real physical event, with real kill mechanisms and real selectional consequences, but it should not absorb the whole frame. It changed which branches carried forward. That is what counts enormously. But it did not set a destination, and it did not work alone. To understand what it actually did, you need to know what happened to the living world in the years immediately after impact. Not the spectacle of the strike itself, the physical reality that followed. So what did the famous impact actually do to the living world in plain physical terms? Think of a greenhouse in winter. You pull the grow light out of the socket. Nothing explodes, nothing burns. But give it a few weeks and the tomatoes stop producing. The herbs go yellow. The insects that fed on the plants have nothing left. Whatever fed on those insects is next. The light was the first domino, and it never touched a single creature directly. It just stopped arriving. That is the closest everyday image for what followed Chicxulub. The strike itself was enormous. You already know that part. But the strike was not the main event for the living world. What came after was rock and debris vaporized on impact and shot into the upper atmosphere. Soot from wildfires joined it. Sulfur aerosols joined that. Within weeks, a dense layer of particles was filtering the sunlight, reaching the surface. Researchers studying sediment cores from the Gulf of Mexico, rock layers laid down right at the impact boundary, found chemical signals of rapid surface cooling arriving almost immediately after. Cold water indicators appearing in the record within a geologically brief window. The sky was not working the way the living world needed it to. The plants felt it first. Photosynthesis runs on incoming light. Pull that light down far enough and the chemistry slows. Pull it further and it stops. At the base of nearly every land food web on Earth, that chemistry was the source of everything. When producers fail, consumers follow. Insects, small vertebrates, anything that ate plants. The failure propagated up the chain the same way the greenhouse collapse propagates through your tomatoes, not in a single day, over months, over years, but steadily because the energy input had been cut. This is the mechanism worth carrying with you. The asteroid did not simply hit hard and thereby generate a human future. It triggered a kill chain that ran through light and food. The chain was concrete, each link followed from the one before. Dark and cold are not dramatic the way a fireball is dramatic, but they are thorough. They reach everywhere sunlight used to reach, which is everywhere that life had organized itself around photosynthesis. What came out the other side was a world with most of its large body mass gone, and most of its ecological roles emptied. A reset system. Whoever survived was not inheriting a stable world, they were inheriting a vacancy. And that inheritance question turns out to be brutally practical, not mythic. If you imagine that reset from inside the food web, the question becomes very plain. What could still eat? What could still breed? What could still hold on until the light came back? If the sky went dark and food chains collapsed, who was left to inherit what came next? Mammals were left. But that answer needs unpacking, because the inheritance was not clean. Think of a tournament bracket where one side gets cleared out. The space is real. The matches on the other side still have to be played. That is closer to what happened after Chicxulub than the cleaner story most people carry around. The cleaner story goes like this. Dinosaurs gone, mammals in, humans eventually arrive. One era closes, another opens, the line runs straight. It is tidy. It is also wrong in a way that makes the difference. What the fossil record from that boundary actually shows is branching and loss. Many mammal lineages that crossed into the New World did not last long inside it. The cleared ecological space was real, large body mass was gone. Many roles sat empty, and smaller warm-blooded animals were suddenly not competing with animals 50 times their size. That part of the story is true, but the next part is not a single mammal wave rolling forward. It is a set of separate experiments, most of which ended without descendants. The work coming out of sites like the Ojo Alamo and contemporaneous formations in the years around the 2010s helped trace just how uneven that inheritance was. Different lineages, different outcomes. Some lines expanded, some stalled, some vanished inside a few million years of the crossing. The reset cleared one constraint and left everything else, local conditions, food availability, further climate shifts, still in play. You can imagine it this way. Imagine the vacancy left after a flood in a building. The old tenants are gone, the rooms are open, but which new tenants actually stay and in which rooms depends on who gets there, what the rooms offer, and whether the building keeps flooding. The vacancy is not the same thing as a guaranteed outcome for any particular arrival. What this means for the chain running toward primates is that mammal survival after the boundary is not the end of the narrowing. It is just one more round of it. The branch that eventually produces primates still has to appear inside that surviving mammal diversity, and it is a narrow branch. Most mammal lineages from the early Paleogene are not our ancestors. Most of them are not anyone's ancestors anymore. So the reset removed one massive filter and kept all the others. Mammals inherited the vacancy unevenly, with heavy loss along the way. That is the plain version of what the record shows. And even after mammals inherited the opening, what narrower branch still had to appear? Think of a highway where an accident closes most of the lanes. Some cars still get through, but getting through the bottleneck does not tell you which single car will reach a particular exit 50 miles ahead. Mammals getting through the extinction event was the bottleneck. Primates are a specific exit, and those two things are not the same. The primate branch did not sit waiting inside mammal success like a passenger already on the right bus. It had to open separately from a much narrower point inside the broader mammal field. Researchers Soligo and Smars described primate origins as a problem still shaped by fragmentary fossils and the difficulty of placing early forms in their ecological context. The record is genuinely incomplete. That counts, because it means we are working with partial evidence when we try to say exactly when and where the branch appeared and what conditions held it open. What the record does show is that the mammal diversity emerging from the early Paleogene was wide. Many lineages, most of them are not our ancestors. Most of them are not anyone's ancestors now. The group that eventually connects to primates was one thread inside that wider field, and a narrow one. It is not the inevitable destination of mammal success. It is a contingent opening, something that had to happen separately, under its own conditions, in its own time. You can think of it this way. After the highway bottleneck, hundreds of cars are moving again. The fact that traffic is flowing does not mean any one car is guaranteed to reach your specific exit. That exit still has to be reachable. The ramp still has to be open. Something still has to send one car that direction rather than any other. For the chain that eventually runs toward hominins, this is not a small detail. If the primate corridor never opens inside the mammal field, the later steps cannot happen, not because something blocked them deliberately, but because there was no path to stand on. The corridor had to appear and then persist long enough to matter. We do not have a clean, fully resolved version of events of exactly how it appeared. The fossils from that period are fragmentary. Ecomorphological context, meaning how we read what these animals were doing from their bones and teeth, helps fill some of the gap, but only some. Certainty here would be bluffing. What we can say is that the opening was real. It was narrow, and it required its own specific conditions to hold. Once the primate corridor existed, what kind of pressure kept the chain narrow inside it? You probably imagine it this way. Once some ancestors stood upright, the outcome was basically settled. Intelligence, tools, us, each step following naturally from the one before, like a road that, once you find it, mostly just continues. That story is wrong, and the reason it's wrong counts. Think about dressing for a week when you have no idea what the weather will do. Someone with a single coat, one good coat for one kind of day, does fine when conditions hold. The moment temperatures swing or rain comes in sideways, they're stuck. Someone with layers moves through the same week without much trouble. Same week, same swings, different outcome based entirely on flexibility. East Africa was that kind of week, stretched across hundreds of thousands of years. The Smithsonian's synthesis of the climate record there shows something specific. During periods of strong environmental fluctuation, specialized species were replaced by closely related animals that had more flexible adaptations. Not replaced by something distant or dramatically different, replaced by neighbors that could handle the range. The pressure wasn't harsh conditions building something stronger. Harsh conditions don't sculpt a particular outcome. They just end things that can't adjust. What the record shows is that instability itself sorted the lineages. Specialists did fine while their conditions held. When the conditions swung, the specialists went with them. The more flexible branches stayed. That is a quieter process than it sounds. No single crisis. No single threshold crossed once and never again. Just repeated environmental swings acting as a repeated filter. Each cycle, the branches that couldn't track the range narrowed or disappeared. The ones that could continued. If you slow the image down, the pattern is not dramatic. The chain didn't narrow because something heroic happened inside it. It narrowed because flexibility was the thing that kept a lineage inside it at all. It's worth being clear about what this doesn't mean. It doesn't mean climate drove the outcome by design. It doesn't mean any particular shift was the cause, or that the chain was always going to run in this direction. Climate variability was a condition. Flexibility was what that condition selected for, repeatedly over a long span. The filtering was real. The destination was not guaranteed. So the chain inside the corridor stayed narrow, but not because progress was blocked. Because each round of environmental change trimmed away the branches that had locked themselves into one range of conditions. If you hold that idea in mind, the next question becomes less abstract. What did flexibility actually buy on the ground? Which raises the question that follows from this. Flexibility kept certain lineages in the chain, but what exactly was flexibility buying, generation after generation, that the specialists could not hold on to? Think about a business that sells one thing. It works fine while demand is steady. But when the market shifts, that business has one move: keep selling the same thing and hope the world comes back. Sometimes it doesn't. The businesses that survive a shifting market are the ones that can change products, change prices, change who they're selling to, not because they're smarter in some abstract way, because their range of response is wider. That's close to what you're seeing in the hominin record during periods of strong climate oscillation, when environments were shifting, cycling through wet and dry, warm and cold, open and forested. The lineages that stayed in the chain were not necessarily the ones with one very refined adaptation. They were the ones that could respond to changing demands, new food sources, new terrain, new pressures on how groups moved and cooperated. The Smithsonian's Human Origins research ties major expansions in behavior and innovation directly to those periods of instability, not calm stretches, the turbulent ones, which makes a kind of ecological sense. If conditions are stable, a narrow specialist can thrive. One good tool, one reliable habitat, one proven food source. Stability rewards focus, but when the ground keeps shifting, focus becomes a trap. You've optimized for a world that no longer exists. What flexibility was buying, generation after generation, was options. You can think of those options in plain physical terms. The ability to shift diet when one resource collapsed, the ability to move when a region dried out, the ability to learn new behaviors within a lifetime, rather than waiting for slow biological change to catch up. If you imagine the chain from inside one of those lineages, that wider range is what kept the next move available. None of that is one heroic trait. It is not bigger brains as a simple engine that made the outcome inevitable. It is a broader capacity to cope, in behavior, in social coordination, in the range of environments a group could actually live in. And here's the part worth sitting with. The close relatives of your ancestors faced the same oscillating world, the same dry spells, the same forest retreats, the same instability. The pressure was not unique to one line. What differed was the response. Some lineages narrowed, some held a wider behavioral range. The ones that narrowed are gone. The ones still threading through the corridor are the ones that kept finding another move when the last move stopped working. If you read that from inside the chain, the difference is almost modest. One line keeps a few more options open, another line runs out of them. That is not a story about destiny. It is a story about range. A wider set of responses kept certain lineages present while others dropped out. Not because the future was written for them, because they hadn't run out of answers yet. And if close relatives faced the same shifting world, why did they not share the same future? Think about two boats crossing the same storm. Same waves, same wind, same night. One carries a full repair kit, extra rope, spare timber, a crew that has handled a cracked hull before. The other has fewer options. The storm doesn't choose a winner. The difference is what's already on board. That's roughly the view when you look at late Homo sapiens and Neanderthals side by side. They were not strangers to each other's world. They overlapped in time and in geography. They faced the same cycles of warming and cooling, the same shifting ranges of the animals they hunted, the same landscape that could open or close depending on the decade. The Smithsonian's synthesis of the human origins record shows they did not respond to those fluctuations in identical ways. Broader social networks, more specialized and varied tools, wider exchange of resources across distance, these show up unevenly between the two lines, not as proof of one being smarter or better, as differences in what was on board when the storm arrived. You might think by this point in the story the outcome was already settled. We're here after all. It can feel like that makes us the obvious survivors, the ones who were always going to make it. But that's reading the ending backward. Neanderthals were not a failed experiment abandoned early. They were a long-running lineage with a real presence in Europe and Western Asia for hundreds of thousands of years. Their disappearance was not quick, it was not clean, and nobody should give you a single neat cause for it, because no one has one. Climate shifts, population pressure, competition, interbreeding, all of it is part of the record. None of it alone closes the case. What the comparison shows is something quieter and more important. Even close relatives do not inherit the future by default. Shared ancestry does not mean shared outcomes. The later human story, right up to the edge of what we call modern, is still a story of loss, of lines that ran out of answers before the pressure let up. You are not descended from the inevitable winner. You are descended from one of several lines still present when the window stayed narrow. The family tree, as far back as we can read it, was never a straight march from simple to complex to us. It was crowded, it was lossy, most branches ended. What does that do to the old mental image of human evolution as one straight ladder? Imagine what you probably saw on a poster in school or in a museum hallway. A row of figures marching left to right, stooped at first, then gradually upright, until the last figure stands tall and unmistakably human, clean, linear, a single path from then to us. That image is wrong, not slightly off, structurally wrong. The Smithsonian's human family tree lays out what the fossil and genetic record actually shows, and it looks nothing like that march. It looks like a tree, a real one, branching and rebranching, with dozens of separate lines spreading out across time and geography. Most of them end, not at a destination, just end. A species appears in the record, persists for some span of time, and then goes quiet. No descendants, no continuation. The line simply stops. Think of a family tree after a fire. You can still read some of the branches. There are names, dates, connections, but many of the lines trail off before they connect to anything. Gone, and the parts that survived were not necessarily the most impressive-looking limbs on the original tree. They were just the ones that were still standing when the fire came through. That is closer to what the hominin record looks like. The ladder model does something subtle that the tree model undoes. It makes every earlier form feel like a step toward us, like the whole story was aimed in our direction. But a branching tree has no aim. Each branch is its own experiment. Homo sapiens is not the finished product at the end of a conveyor belt. We are one surviving branch in a structure that was genuinely crowded at several points in its history, with close relatives living alongside ancestors, lineages that lasted hundreds of thousands of years before disappearing, and no obvious reason to assume our branch was the favored one. Once you see it that way, survival starts to look narrower, less flattering maybe, but closer to the truth. The point is not to memorize which species appeared in which period. Names and dates matter less here than the shape of the thing. The shape is branching. The shape is loss. Many lines that were present are not present now. Most of them, actually. And the ones that ended were not failures in any meaningful sense. They were just lines that ran out of time before we did. Which leaves a question sitting right at the edge of that version of events. If the tree was genuinely crowded, and it was, how many of those branches had to end before ours was the only one remaining? If the tree was crowded, how many branches had to end before ours remained? Think of a building at night. Long hallways, doors on both sides. Most of the doors are dark now, locked. The lights behind them went out a long time ago. You can walk through the one corridor that stayed lit, and from inside it, the building looks fine, functional. but the dark doors are still there if you look. That is roughly what the hominin record looks like. One lit hallway, many doors that no longer open. The Smithsonian's catalogue of our family tree lists more than a dozen distinct hominin species, relatives who walked upright, made tools, raised young, and then disappeared. Paranthropus boisei, with its broad flat face and heavy jaw, lasted over 1 million years before it ended. Homo naledi left its dead in a cave in South Africa, which suggests something like deliberate ritual, and then vanished. Homo heidelbergensis spread across Europe and Africa and gave rise to at least 2 different descendant lines, and then the line itself was gone. These were not sketches. They were full species, with ranges and adaptations and long runs of time, and they are not here. You have probably heard the story told as a rise, one line getting stronger, outcompeting the others, eventually taking over. That story feels satisfying. It puts our branch at the center. But the record does not really support it. Survival is mostly visible from the inside. The species that ended left no one to describe what they lost, no one to say what those populations experienced in the decades before the last of them died. We see the gap, and then the silence, and we call it the past. What we do not see, because we cannot, is what it looked like from their side. So the question shifts. By the time our branch was the only one left, the right thing to ask is not how we rose. The right question is how many neighboring lines ended, dozens of relatives, some of them overlapping with our own ancestors in time and space, all of them gone. And here is what that actually means for us. Even being the surviving branch does not mean the surviving branch was ever secure. The last door still lit in a building where most doors went dark is not the same as a door that was always going to stay lit. And even once our branch remained, how secure was it really? You might imagine it as a wide river, broad, deep, carrying enough water that a drought here or a blockage there would not threaten the whole flow. Our line survived after all. It is easy to assume that survival implies a certain width, a certain margin. But one genomic study published in 2023 looked closely at the inherited variation in our DNA and found a different story entirely. The research, led by a team including Hugh and colleagues, inferred that somewhere between about 930,000 and 813,000 years ago, the ancestral population feeding our line may have pinched down to roughly 1,280 breeding individuals. That is not a population, that is a small town. And that pinch, according to the model, held for something like 117,000 years. 117,000 years is longer than modern humans have existed as a species. The whole time, the line that would eventually become you was threading through a gap not much wider than a canyon. And think about what that means in physical terms. A wide river narrowing into a slot canyon before it ever gets to spread again downstream. The water that makes it through carries the full burden of everything that comes after. If the canyon closes entirely, the river stops. What gets through is not the whole river, it is one surviving thread. Now, a boundary worth keeping in mind. This result comes from a computational model reading signals in modern DNA. Models of this kind are powerful, and this one has been taken seriously by researchers in the field, but they are still models. They infer population size from patterns of genetic similarity and difference, and those patterns can be shaped by things other than a single clean bottleneck. The full image of what was happening across all ancestral populations over those 117,000 years is not something any model can completely recover. So the finding deserves attention, not certainty. What it does tell you, even with that boundary in place, is that even the surviving branch was not necessarily safe. Even the line that eventually led here was squeezed. The contingency you might have thought ended with extinction events and vanishing cousins did not end there. It continued inside the line itself, inside a population small enough that bad weather, a disease, a single hard season in the wrong place could have closed the canyon entirely. If our line really did narrow that far, then the question of how any one person came to exist gets sharper still. You are not just downstream from a surviving branch. You may be downstream from a thread. Even after the line survives, what still separates one species from one future person. Even after the line survives, there is still a long way to go before you. Think about a railway network. Say the whole system stays running, every line, every station, every track. That tells you trains are moving. It does not tell you one specific passenger boarded one specific train on one specific night and sat down in one specific seat. The network surviving is a much broader fact than that one journey. Homo sapiens surviving is like the network staying running. Your particular family line reaching the present is the seat. When our species spread out across the planet, it did not move as one tidy column. Groups split. Some followed coastlines, some pushed inland, some crossed into new territory and never made contact with the groups they left behind. Some of those separated populations shrank. Some disappeared from a region entirely. Others merged with groups they encountered along the way. Every split, every migration, every local disappearance produced a different set of people who could possibly carry the line forward. And the line narrowing logic you have already heard, the one about deep time, about populations shrinking and recovering, that same logic did not stop when the species was no longer in danger of vanishing entirely. It kept operating at smaller scales. A group that survived in one valley was still not guaranteed to produce one particular pairing 200 generations later. The people in that valley still had to meet specific other people. They still had to survive specific seasons. They still had to move in specific directions and not others. Species survival settles one question. It leaves the next question completely open. This is the part that can be easy to skip over. Once you hear that Homo sapiens made it through, the instinct is to treat the rest as detail. The species survived, populations grew, and eventually the later family story filled itself in. But that is not how it worked. The later family story was not filled in. It was chosen, one contingent event at a time, by migrations and encounters and pairings that had no obligation to produce any one eventual person. Your ancestors still had to find each other, in the right place, at the right time, out of everyone alive in that place and time who they did not find instead. Keeping the railway network running does not put anyone in any particular seat. It just means the trains are still going somewhere. So the story does not end at species survival. It only changes scale. It moves from a question about a branch to a question about the people inside the branch who found whom and where and when. If species survival is still too broad, how does the story narrow into one eventual family line? Imagine a family photograph, not an old one necessarily, just a finished-looking image, a group of people arranged together, smiling, holding still. It looks like a record of something established, complete. You look at it and your eye reads it as a unit. But here is the thing about that photograph. The person at the center of this story is not in it, and depending on how a handful of ordinary days go, they may never be. You might assume that once the earlier generations are alive and producing children, the rest follows, that the line just continues, that descendants accumulate the way a river keeps flowing once the headwaters are full. That assumption feels reasonable. It is not quite right. Think about missing a train connection. You miss it by 4 minutes. You catch a different train. By nightfall, you are in a completely different city, talking to completely different people, sleeping in a place you had never planned to see. Nobody made a dramatic choice. Nothing broke. One small delay changed everything downstream. That is what each generation of a family is doing, whether it knows it or not. A migration happens or does not happen. An illness keeps someone home on one particular evening. A war ends 2 years earlier or 2 years later. A person gets introduced at a gathering they nearly skipped. Every one of those bends the line toward different people or toward no meeting at all. Earlier survival does not bank anything. It does not guarantee particular descendants. It only means the line is still moving, but moving toward whom and through which pair of people stays open right up until it is not. This is not about fate in either direction, not about two people being destined to find each other, and not about the universe working against them. It is simpler than that. It is just that the number of possible people a given line could produce stays very large long after the line itself is secure. And most of those possible people do not arrive. Most branches are never followed. So even if you already know your grandparents found each other, the chain is still narrowing, still being decided, one meeting at a time. The photograph looks finished, but the seat at the center of it is still empty. And once the family line is real, what does timing still have the power to change? More than you might expect. Because the question isn't finished just because the right people exist. It's still being answered even then. Think about catching a train. You make it by 10 seconds. You sit down, the doors close, and you end the day somewhere completely different from the person who missed it. Not a different life in some dramatic sense. A different Tuesday, a different street corner at a different hour. And from there, everything that follows shifts. Who you run into, where you stop, what you say. The destination changes because the timing changed. Nothing else had to. And that is what timing does inside a family line, too. Your parents had to be in the same place, on the same day, at a moment when meeting was possible. Not just in the same city or the same decade, the same afternoon. A month earlier, a different shift, a cancelled plan that didn't get cancelled, and the meeting either doesn't happen or it happens and produces someone else. Not you, not the person you're aware of being right now. This isn't about destiny or its absence. It's about how narrow the window actually is when you look at it plainly. The family line surviving was one kind of narrowing. Who within that line gets to exist is another, and it runs on timing as much as anything biological. Two people can share every ancestor and still not share an existence. The days have to line up, the hours have to hold. And this is ordinary. It's not rare or tragic or remarkable. It's just how person-level contingency works once the species-level questions are settled. Once we're past extinction and war and the collapse of whole populations, the filter doesn't disappear. It scales down. It becomes a morning schedule. A train arrived at the wrong platform. A conversation that lasted 5 minutes longer than expected, or 5 minutes less. Most of the possible people that a family line could have produced never arrived. Not because anything went wrong, because timing is a filter too, and it runs continuously from generation to generation, all the way down to the exact circumstances of a single evening. You are one outcome out of a very large number that could have followed from the same starting conditions, and the conditions that selected for you, specifically, weren't only about survival. A lot of it was just timing. Which brings the question down one more level. Not to history, not to chance meetings, but to something smaller. And once the family line exists, what does biology still have to narrow next? Think about shuffling 2 decks of cards. You can shuffle them both as many times as you like, and the possible combinations stay enormous. You haven't drawn the one pair that actually gets played yet. That moment is still ahead. That's roughly where things stand before fertilization. Every human egg and every sperm carries 23 chromosomes, half the usual amount. That halving is what meiosis does. It divides the full set, producing cells built for one purpose only. Each one is genetically distinct from the others produced in the same body. Your mother was generating those cells. Your father was too. The process doesn't stop between generations. It keeps running. Here's where a reasonable assumption breaks down. Once your parents existed, once those 2 specific people were alive at the same time, it might seem like the personal question was basically settled. The right 2 people were in place. The family line had arrived, but the biological target was still moving. Your mother didn't carry one fixed egg waiting to become you. She carried the potential for many genetically distinct eggs, each one a different shuffle of her own chromosomes. Your father was producing sperm continuously, each one carrying a different arrangement. The 2 decks were being reshuffled the whole time. Not one combination was locked in yet. So the narrowing that happens before fertilization isn't just about which 2 people exist. It's about which particular cells, out of all the genetically distinct ones being produced by those 2 people, happen to meet. The chain is still specific, it's still exact, and it's still running. You are the result of one pairing out of a very large number of possible pairings between your parent cells. Your siblings, if you have them, came from different pairings. Same two people, different shuffles. Genuinely different people as a result. Not just different in the way two copies of the same book might vary, but different in the way two entirely distinct cards drawn from the same two decks are different. The biological answer to who gets produced doesn't wait for fertilization to begin narrowing. It starts narrowing inside each parent, at the cellular level, continuously, long before any particular conception. By the time fertilization happens, most of the possible people that those two parents could have produced together were already unreachable. The shuffle had already moved past them. So the last narrowing isn't something that happens in a single moment. It's a process with a physical location, a physical mechanism, and a physical sequence. And the final step of that sequence has a specific shape. If timing is the point, what is the last narrowing in strictly physical terms? The last narrowing is a physical event with a physical location. It happens in the fallopian tube, and it looks like this. One sperm reaches one egg. Not a population of sperm blanketing an egg in some general way. One. Out of tens of millions that began the same journey, one makes contact, enters, and the egg closes behind it. What results is called a zygote, a single cell, and that cell contains 46 chromosomes, 23 that came from the sperm, 23 that came from the egg. That's the full human count, restored. The sperm carried half a deck, the egg carried half a deck. Now they're one complete deck, and the specific cards in it will never be assembled in that exact arrangement again. If you imagine that moment closely, the physical specificity is hard to miss. Each of those half-decks was already shuffled before this moment. The chromosomes inside that particular sperm were a unique combination drawn from two grandparents. Same for the egg. So when they close together, you're not just watching one sperm meet one egg, you're watching two already shuffled half-decks finally close into one exact full deck. 46 chromosomes, billions of possible arrangements that will never exist because this particular arrangement now does. The misconception worth naming here is that this step is too familiar to carry any scientific weight. You've heard about sperm and eggs since middle school. The words feel like background noise, but familiarity is doing something quiet and misleading. It's making a precise physical event feel like a formality, like the last page of something that was already written. It wasn't written. This event is where a specific biological identity becomes fixed at the chromosomal level, and it required one sperm out of tens of millions arriving in the right place within a window measured in hours. A different sperm enters instead. Different person, same egg, different timing, and the egg was no longer viable. No person. A different egg had matured that cycle instead. Still different person. None of those outcomes involve fate or metaphor. They follow from which cell was present, when, and whether the chemistry allowed entry. Your chromosomal identity, the version of a genome that eventually built whatever you are now, was fixed at that contact. Not gradually, not symbolically. At one moment, in one location, when one cell entered another and the membrane closed. That's what the last narrowing actually is. One physical event with one physical outcome. And once it happened, a great deal became fixed. But not everything. The question now is what exactly was locked in at that moment, and what had only just started. Once one sperm and one egg meet, a great deal becomes fixed. But fixed is not the same as finished. That distinction is what counts, and it takes a moment to feel clearly. Think of a room full of dominoes. Someone has spent hours arranging the whole line. Every piece placed, every gap measured, every turn in the path accounted for. And then, finally, the first domino tips. That first fall doesn't mean the display is over, it means it has started. The arrangement that took so long to build has begun to express itself. That is roughly what happens when fertilization is complete. The egg activates, and an activated egg, with the right signals now present, can begin developing into a complete new individual. That is not a metaphor. It is a description of what activation does, documented in basic cell biology. The cell has been tripped. The line is falling. What follows is not a sentimental coda. Some people hear fertilization and imagine the hard part is over, that everything after is just growth playing out the way a movie plays after you press start. That idea is wrong. The zygote is not a finished organism paused at its smallest size. It is a single cell that is about to begin doing something extraordinarily precise. Within hours, the zygote starts dividing. That first cleavage, and the ones that follow, are the earliest steps in a process that determines which cells become which tissues, which signals get sent in which direction, which structures form and when. Each division is an event in itself. The fetal development record is clear on this. Early cell divisions begin immediately and set the conditions for everything that follows. You are watching, in that first day, the opening moves of a process that will run for months and produce something with a working nervous system. For you, this is the point where the chain becomes exact at one scale and still open at another. So what was locked in at fertilization? The chromosomal combination, the genetic identity of that particular cell, the version of a genome that would eventually organize the whole development. That is genuinely fixed at the moment the membrane closes. But the developmental path that genome will actually take, the timing, the environment, the signals the dividing cells will receive, that is not totalized by fertilization. It has only just started being determined. This is why science cannot truthfully produce a single number for the whole chain. Not because the math is hard, because the chain does not end here. What fertilization closes is the last major biological narrowing: one sperm, one egg, one cell, one genome, specific, exact, unrepeatable. But specificity at fertilization is not the same as certainty about what comes next. And that gap, between the final event being exact and the whole probability being impossible to total, is exactly where we need to go. Here is the tempting view. You have a long chain of filters. Each one has some probability, so you multiply them together and out comes your answer. Clean, satisfying, done. The problem is that the chain does not work that way. Start with the first link, whether a world is even habitable. You might imagine that as a yes or a no, habitable or not. But habitability does not snap between two states. It grades. A planet can be partially right, the right distance from its star but with too little water, or the right water budget but the wrong atmospheric pressure. Researchers who have tried to score habitability across dozens of variables find that the answer keeps arriving as a spectrum rather than a switch. That already breaks the simple multiplication mental image, because you cannot fairly plug a gradient into a formula that expects a single clean probability. Then comes the sequence of biological steps, and those carry their own trouble. Think of an old combination lock, the kind where each ring has to click into place before the next one can turn. Biology does not move like that. Long stretches go by with almost no visible change, and then a threshold gets crossed and a new kind of complexity becomes possible. The timing of those thresholds is not random noise. Earlier conditions pace later ones. Researchers studying major transitions in evolution have found that the gap between simple cells and complex cells alone lasted close to 2 billion years, and that gap appears to be structural. It was waiting for metabolic and genetic groundwork to be laid. That is not an independent roll of the dice. It is a staged sequence where each phase opens or closes certain later possibilities. Even the narrowing points that look most measurable turn out to carry real uncertainty. Take the population bottleneck that appears in human ancestry around 300,000 years ago. The best current estimates suggest the founding population was very small, perhaps under 2,000 individuals. But those figures come from models built on modern genomes, and researchers are candid that the numbers shift as the models are refined. A bottleneck that tight is genuinely striking, but its exact depth is not a settled measurement. And underneath all of this runs a subtler problem. Later evolutionary paths depend on which substitutions happened earlier. Change a mutation 2 billion years back, and the landscape of what becomes possible downstream shifts with it. The locks keep changing shape depending on which earlier lock opened first. That is path dependence, and it means the filters cannot be treated as 12 separate, independent events that you simply multiply together. If you follow that logic all the way, the whole neat multiplication version of events starts falling apart right there. And none of this is an argument against careful calculation. Calculation is how science got this far. The point is simpler. Staying inside the evidence keeps the numbers trustworthy. So, if no clean total survives, what is the strongest fair answer science can actually give? So if no clean number survives, what is the strongest fair answer science can actually give? It is this: your existence was possible, and it was never written in advance. Both of those feel like a letdown if you came looking for one clean verdict. But the fair answer is actually stronger than either extreme, because it holds up. It doesn't collapse the moment someone asks for the working. If you want the cleanest plain version, think about finishing an audit. You go through every line item, the revenues, the costs, the adjustments, the corrections, and at the bottom someone has written in a total that doesn't follow from anything above it. The lines above it are real. The work that went into each of them is real. But that final number is invented. The right move is to cross out the fake total and keep every real line above it. That is what the evidence actually supports. A long column of real, documented entries, with no magic number at the bottom. And that column is not thin. It runs from how the universe tuned its physics, through the slow acquisition of a planet with the right persistence, through a delay of billions of years before complexity appeared at all, through mass extinctions that cleared some paths and closed others, through a narrowing of lineages that could have run 100 different directions, all the way down to one specific biological event that had to resolve the way it did. Each of those entries is real. Each has evidence behind it. None of them was a guarantee. Now, 3 answers you sometimes hear refuse all of that at once. One says it was a miracle. One says it was destiny in statistical clothing, a number so small it proves design. One says science has nothing to say because it cannot produce a single probability. None of those are truthful. The first 2 reach past the evidence. The third confuses careful limits with silence. Science has quite a lot to say. It just says it line by line, not in one theatrical sum. Here is what that leaves you with. Every step in the chain was contingent. That means it depended on conditions, and conditions could have differed. The chain that led to you was long, it was narrow, and it was real. You don't need a number for that to mean something. The length and the narrowness are themselves the finding. And when we return to that bracelet, the one from the very beginning of tonight, what does it mean now? It means a very long column of real things happened, each one depending on the ones before it, and the last line in the column is a person sitting quietly in the dark, listening. And when we return to that bracelet, what does it mean now? It means one exact zygote, one out of all the timing windows that opened and closed in your parents' lives, stayed open at the right moment. That zygote carried one exact combination of 2 genomes, each assembled from 2 more, going back without a break, one surviving family line on your mother's side, one on your father's, both of them unbroken across wars, famines, migrations, plagues, accidents, and the ordinary bad luck that erases most lines quietly and without ceremony. Behind the family line sits a human branch, one species that made it through at least one near extinction, maybe more, and came out the other side with enough survivors to keep going. Behind the human branch sits a planet that stayed in its usable range long enough to keep liquid water, a stable enough climate, and a magnetic field that held so life could run its whole experiment. 4 billion years is a long time for conditions to stay friendly. They didn't have to. They did. And behind the planet sits a universe that permitted the chemistry in the first place. The constants landed where they landed. Hydrogen formed. Stars ran long enough to build heavier elements. Those elements scattered. One star made the right debris field. None of that required your arrival. It just didn't prevent it. You don't need destiny language for any of that. What you need is a clear-eyed count of how many real filters existed, and a willingness to notice that each one stayed open. Not because of you, before you. The chain is meaningful not because it aimed at something, but because it was genuinely long, genuinely narrow, and genuinely real. If you trace that count back from the bracelet, the striking part is not magic. It is how many ordinary openings had to remain open in sequence. Here is the edge that is still worth sitting with. The alternatives, the lines that broke, the timing windows that closed, the planets that didn't stabilize, the family lines that ended without descendants. Those left almost nothing behind, no record, no signal, no one to look back and notice they didn't make it. Which means hindsight still lies. You can trace the chain backward and feel a kind of weight to it, a sense that each step was pointing forward. But that feeling is your own mind filling in a direction that the chain never had. The silence of the alternatives is the silence of every path that didn't arrive anywhere. And because they're silent, you can't feel them alongside you when you look back. That makes the one path that worked look more inevitable than it ever was. The bracelet is a late result of a radically contingent history. It could have said someone else's name, or it could have said no name at all. The filters were real, the openings were real, and one chain ran all the way to a person in the dark, wearing a small plastic band with a name on it. Not chosen, not aimed at, simply the last link in a chain that stayed intact and happened to end here. That's a colder meaning than destiny. It's also a cleaner one.